section 9.1, but before we get into it, I just want to remind you of some stuff we did back in chapter 6, and that is determining whether it's possible to form a triangle with the given side lengths. So if I took the smallest two sides and added them together, it's supposed to be greater than the third side. So in this case, 13 is greater than 10, so the answer would have been yes, it is possible to make a triangle with those side lengths. Whereas for the second one, if I took the two smallest numbers and added them up, I get 12, and 12 is not greater than 12, so no, that would not make a triangle. The other thing we talked about is if you were given 5 and 9, I'm just going to make some sides up. If you were given these values and you wanted to know the possible values to make a triangle, if you recall, we put subtracting them on one side and adding them on the other. So it would have to be between 4 and 14. That's going to come into play later in our lesson. So this lesson is about the Pythagorean theorem, which is how we find the missing side of a right triangle if we already know two sides. The hypotenuse, or the side across from the right angle, is C, and the other two sides, the legs, are A and B, and those are interchangeable. And normally you've probably seen it as a squared plus b squared equals c squared. We're going to write it as c squared equals a squared plus b squared, just because it's also going to help us in the later parts of this lesson. There's something called a Pythagorean triple, which is a set of positive integers that work in the equation. They're not required to memorize, but they're definitely helpful to know. So these are the most common Pythagorean triples, and they're multiples. So 3, 4, 5, multiply that by 2, we get 6, 8, 10. By 3, we get 9, 12, 15, and so on. 5, 12, 13 is a common Pythagorean triple. 8, 15, and 17, 7, 24, and 25, and many, many more. For our first problems here, we're going to find the value of x and then determine if we have found a set of Pythagorean triples, which just means were all three numbers in the triangle whole numbers. So this side, if this is the right angle, this is my c. So we're going to do 5 squared equals x squared plus 3 squared. So that's going to be 25 equals x squared plus 9. I have to subtract the 9 before I can take the square root. And I get x is 4. So that means the sides of my triangle were 3, 4, and 5. So yes, they did form a Pythagorean triple because all three of those numbers were whole numbers. For the second one, if this is my right angle, across from that is c, so this time x is c. So 6 and 4 are my a and b. It doesn't matter what order I put those in. I'm going to square these first. So 6 squared is 36. 4 squared is 16, and now I'm going to add them together. And now I could take the square root of both sides. We could either write this as a reduced radical, or we can write it as the decimal. It depends on what they're really asking us to do in the problem. For the most part, decimals will be totally fine. But if you're going to have to reuse the number you just got, the radical would be the way to go. But this answer is 7.21, so that means my sides are 4, 6, and 7.21, which is not a whole number. So no, this was not a Pythagorean triple. So you can go ahead and try this one. Pause if you'd like. Answers are posted online. For example 2, a telephone pole breaks and falls as shown. To the nearest tenth of a foot, what was the original height of the pole? So the original height of the pole will be this value plus this value added together. I know this value, but I don't currently know this one. It happens to be my c. So I'm going to I'm going to do Pythagorean theorem first. So c squared equals 6 squared plus 9 squared. So that's going to be 36 plus 81. C squared is the square root, or c is the square root of 117. So c is 10.82. So that means the height is really 6 plus 10.82, or 16.82. And they said to the nearest tenth of a foot, so we'll say 16.8 feet. For try 2, you can pause. If you want to give it a try, answers are posted online. The converse of the Pythagorean theorem, remember converse means the reverse order. So before we knew if it was a right triangle, then c squared would equal a squared plus b squared. Now we're saying if c squared is equal to a squared plus b squared, then it is a right triangle. So this will help us determine if the sides of a figure form a right triangle or not. So in choice A, the biggest side is going to have to be my c value. And in this case, the square root of 113 is bigger than 10 because the square root of 100 is 10. So this is my biggest side. So we're going to check, is the square root of 113 squared equal to 8 squared plus 7 squared? When I square the square root of 113, I just get 113 back. So now I have 113 is maybe equal to 64 plus 49. If I add 64 and 49 together, I get 113. So yes, this is a right triangle. For B, 4 root 95 is 4 times almost 10, so it's almost 40, which is going to be the biggest side. So we're going to have 4 root 95 squared is maybe equal to 36 squared plus 15 squared. So this is trickier because when I square the square root of 95, I just get 95, but I also have to square the 4. So this is really going to be 4 squared, or 16, times the square root of 95 squared, which is 95. So if I do 16 times 95, I get 1520. If I do 36 squared, I get 1296. And 15 squared, I get 225. So together, that's 1521. So 1520 is not equal to 1521, so no, this is not a right triangle. What we really want to look at is what kind of triangle would this be if this was my result. And if I'm looking at 1520 compared to 1521, that's really less than it, right? 1520 is less than 1521. So this would make sense. The symbol of less than belongs with what kind of triangle? It's going to belong with an acute triangle. So if you have a less than symbol when you do c squared is something to a squared plus b squared, it's really an acute triangle. If c squared is greater than a squared plus b squared, it's an obtuse triangle. All right, and this is the reason our c squared must go first, because that's the only way our symbols make sense. So we're going to classify each of these as acute, obtuse, or right. The biggest side here is 6.1. So I'm just going to leave a blank space here because I don't know what symbol is going to go in there. All right, so 6.1 squared is 37.21. And I'm actually going to put this in my calculator together. I'm going to do 4.3 squared plus 5.2 squared, and I get 4553. So I have less than, 37.21 is less than 45.53, so this is an acute triangle. For the next one, 6 is my biggest. So I'm going to have 6 squared is something to 3 squared plus 4 squared. So 6 squared is 36. Again, putting this right into my calculator, 3 squared plus 4 squared, 9 plus 16 is 25. So I have 36 is greater than 25. So greater than would make this obtuse. All right, for my third one, 3.5 is my biggest side. So we're going to have 3.5 squared is something to 2.1 squared plus 2.8 squared. So 3.5 squared is 12.25. And when I put 2.1 squared plus 2.8 squared on my calculator, I get 12.25. So that's equal. And from the original part of our converse, equals is when it's a right triangle. So if you'd like to pause and try these problems, the answers are posted online. All right, and now for some honors only questions. We're going to look at finding the possible side lengths of the third side of an acute triangle with side lengths of 18 and 25. If they didn't specify the type of triangle, we could do what we did in the do now and just subtract them at one end, add them at the other, and say it had to be between those. But that would make any kind of triangle. That would make an acute, an obtuse, or a right. So we need to narrow it down to just acute. We know that acute triangles are c squared is less than a squared plus b squared. We also know two of the sides are 18 and 25, so it could be a small number, 18 and 25, or it could be 18, 25, and a bigger number. So we need to take care of both scenarios. So if 25 was the biggest, we would have 25 squared is less than x squared plus 18 squared. But if x was the biggest, we would have x squared is less than 18 squared plus 25 squared. So 25 squared, oops, is 625. 18 squared is 324. If I take 324 away, we get 301. And now I could take the square root. Doesn't matter that it's a less than sign. And we get 17.35. And if I do the same thing over here, we have 324 plus 625. And now we're going to take the square root of that. So I have x is greater than 17.35, and I have x is, sorry, I put the wrong symbols on this one. Now that I'm realizing, I was good at first. Or x is less than 30.81. So really x is between 17.35 and 30.81. So we're going to write our answer as a compound inequality where x is between these two values. And that is the possible side lengths to make an acute triangle. So here's one for you to try. Pause if you'd like. Answers are posted online. For example 6, we're looking for now an obtuse triangle. Same scenario exists. X might be a small number, x might be a big number, but now we're going to be dealing with c squared is greater than a squared plus b squared. So we have one instance where it's 35 squared is greater than x squared plus 13 squared, and one instance where it's x squared is greater than 35 squared plus 13 squared. So 35 squared is 1225. 13 squared is 169. So I have 1056 is greater than x squared. Take the square root of both sides. And we get 32.5. And over here, we have 1225 plus 169. Oops. Can't use calculator today. So x squared is greater than 1394. Take our square root. X is greater than 37.34. So now x is less than 32.5, but greater than 37.34. That's not the same. I can't think of one number that's going to fit both of these inequalities at the same time. So that means we can't combine them. They have to stay separate from each other. But that also means if I'm saying x is just less than 32.5, that would mean x could be negative 8, and we know that x can't be negative values. We know there's limits to what can even make a triangle at all. So we're going to have to include that stuff we remember from the very beginning, where the very smallest number it could have ever been was 35 minus 13, or 22. And the very largest number it could ever be was 13 plus 35, or 48. So that means between 22 and 32.5 is one set of possible answers, or between the 37.34 and the 48 is the other set of possible numbers. So our obtuse answer, O or for obtuse, is going to have two different inequalities They're going to be written as a number less than x less than a number for both. And we're just going to go smallest number to biggest number overall. 22, then 32.5, then 37.4, then 48. That's how we went in order here. So here's one last one for you to try. The answers are posted online, but that is it for section 9.1.